Hello, class. In this lesson, we're going to learn how to divide segments proportionately. So we're going to deal with this segment first, and we're going to draw a right triangle with this segment as its hypotenuse. Sometimes it's called the up and over triangle because used to figure out slopes and distances. And so if we do that, we end up with this triangle. So how long is segment AC? Let's see, this x-coordinate's 12, this one's -4, 12 minus -4 is 16. And for BC, let's see, the y-coordinate's 13, minus the y-coordinate here is 5. That gives us 8. So now I want to look at the halfway point on segment AC. We're going to call that P. What would its coordinates be? Well, this whole thing is 16, so we have to go 8 from one of the endpoints. And that gives us the point 4, 5. Now we want to do the same thing with BC. Where's its halfway point? Well, the whole thing was 8, so we want to go 4, so that would be the point 12, 9. And now we're going to draw a perpendicular segment from P on AC and see where that hits AB. That's nicely at the point M, which is 4, 9. And what happens if we do a similar process with R and segment BC? It also intersects AB at point M. So how do we find M? We found those halfway points and drew the perpendicular segments. And M is a special name. It's called a midpoint. It's equidistant from the two endpoints of the segment. So is there a way that we could find the coordinates of the midpoint algebraically? Let's see. How does M relate to the two endpoints here? Well, 4 is the average of 12 and -4, right? 8 divided by 2. And 9 is the average of 13 and 5, that would be 18 divided by 2. So if we have to find a midpoint, we can just follow this simple formula. Find the average of the x-coordinates, find the average of the y-coordinates. Now we could also think about finding the midpoint in a slightly different fashion. We want to start at point A, so we're going to start with the coordinate -4. And we want to move half of the distance, half of this horizontal distance. And that we figured out was 16 before, so we're going to divide that by 2 and get 8. So 8 plus -4 gives us +4. And that was our x-coordinate. Same thing for the y's. We want to start at 5. And the difference in the y-coordinates was 8, divide that by 2, and we get 4. So 5 plus 4 is 9. And so how can we write this out? Well, here's how we can figure out what our midpoint is. And if we simplify this, we end up with the point 4, 9. So what would be different if we had instead started with endpoint B? How would that change our formula? Well, instead of starting with -4 and 5, if we start at B, we would have to start with 12 and 13. And the other difference is we're not going to be adding here. We're going to be subtracting these distances because we're moving to the left. So the direction is important when you're applying this formula. So let's generalize this. How can we figure out what the coordinates are of a midpoint? Well, the first way we saw was by just finding the averages of the x-coordinates and the averages of the y-coordinates. So these are both the same formula. If we go by what we did in the second process, we started with x1 and y1, and we added 1/2 of these differences. Why do you think we have 1/2 in there? Because we're talking about midpoints, so it makes sense to be talking about 1/2. Now, these two formulas are mathematically equivalent. If we do the work and distribute in our formula for M, we will see that we end up with the first formulas. So x1 minus 1/2 x1 is 1/2 x1, and the same for the y-coordinates. And we can factor out these 1/2s, and that gives us our formula for midpoints. Now, it seems like this formula is a lot simpler than this longer one. And while it's true, we can't use the same idea if we're not looking at midpoints. If we're trying to split segments not into two congruent pieces, we really can't use this method. And so we're going to see that here. Well, if we wanted to figure out a point that's a quarter of the way along that segment, closer to A, what would change in our formula? Well, instead of taking half of the distance, we would take a quarter of the distance. And if we do that, we end up with the point 0.7. I call that point n. And so what formula can we write to find that? Well, we're going to start at a. So our x-coordinate is -4. But this time we're going to add 1/4 of that difference of the x-coordinates. And we end up with 0. Right? Because 12 minus -4 is 16, divided by 4 is 4, plus that -1 is 0. And similar for the y-coordinates, we start at 5, and we add 1/4 of the difference of the y-coordinates, and we get 7. Now, this is the second method we used. If we try to apply a similar idea that we did for midpoint from the first formula, we end up with an answer that's incorrect. If we just find the sum of the x-coordinates and divide by 4, or the sum of the y-coordinates and divide by 4, we get the 0.24.5. And if you look at the graph, that's not even on our segment, so that can't be correct. So we can only use that short formula when we're talking about midpoints. And if we do the math, if we know that our formula up here was correct, and the only difference from our previous formula was we replaced the 1/2 with 1/4. So if we look at the x-coordinates, if we simplify this, we end up with 3/4 of x1 plus 1/4 of x2, which is not the same as our incorrect formula. That would just have the 1/4 as each coefficient. So far we've just been looking at fractions of the form where it's a part of the segment over the entire segment length, the whole. But now we want to figure out where a point would be on a directed segment that divides it into the ratio of 1 to 3. Now we claim that this is the same question as the previous one where we were talking about 1/4. But the ratio of 1 to 3 is not 1/4. Those are different fractions. So why are these really the same problem? Well, in this case, we're looking at parts. In the previous one, 1/4 was a part to a whole. This is a fraction of a part to a part. And so, for example, the smaller piece, we can represent as 1 times some number a. Then the larger piece will be 3 times that same number. So if we look at the ratio of the smaller piece to the entire length of the segment, that would be 1a to 4a, which is just 1/4. So this is really the same problem. So it can be phrased differently, and you have to be careful about how your ratio is given to you, if it's a part to a part or a part to the whole. And also, we use the word directed segment here. All that means is that you're looking at your segment in a certain direction. You're either going from A to B or B to A. So let's do a similar idea, but now we want to figure out the coordinates of a point that's 1/8 of the way along the segment. So the only difference here is that we would divide our differences of the x-coordinates by 8, divide the differences of the y-coordinates by 8. Now, if you notice, we've just been looking at powers of 2. And so it's true that we could have just taken the midpoint of the original midpoint and one of the endpoints to find that 1/4. And we could have done the same thing here for 1/8. But that's only going to work when you're looking at powers of 1/2, when you have powers of 2 in the denominator. So that's not going to extend nicely for other problems. So how else could we restate this problem using a ratio, a part-to-part ratio, and the term directed segment? So we'd be looking at the directed segment from A, which is -4, 5, to B, 12, 13. And the fraction here is 1/8. And that's a part to a whole. So if we look at a part to a part, well, if the whole thing has 8 pieces and we take away 1, that would be 7 pieces left over. So 1 to 7 will be our ratio. So this is a part-to-part ratio. And if our ratio is 1 to 15. Well, this is a part-to-part ratio. So we want to convert it to a part to whole. So we have 1 piece and 15 pieces. That would be 16 pieces total. So our fraction would be 1/16. So divide those differences by 16. And that would be our point. So we have to be really careful. If the problem gives us a ratio in the form part to whole, we're good. We can just use that fraction in our formula. However, if it's a ratio that splits a segment into a ratio of part to part, if they give it to us in that form, we have to convert it to part to whole in order to use it in our formula. And so in general, we can use these formulas. If R is a ratio that compares part of the segment to the entire segment length, we can use one of these two formulas. If we're going from left to right, where x1, y1 is the point on the left, we start with x1, and we add the product of our ratio and the difference of the x's. Now, it's important that you start with x2 and subtract x1. And the same for the y's. Very similar idea. Now, if we're instead going from right to left, we start with x2 and y2, and because we're moving to the left, we have to subtract. But the rest of it stays the same. It's still r times x2 minus x1, r times y2 minus y1. And these points are only ever exactly the same when r is 1/2 because we're looking at the midpoint. So here we have an example where we have a ratio that's 2 to 5, and that's a ratio of a part to the whole, because 2/5 along the segment. So could we use midpoints to figure out the coordinates of this point? No, when we take midpoints, we can only do it when we have powers of 1/2. So 2/5 doesn't work with that. But could we use proportions instead? Yeah, we could definitely use proportions. And so if we look at a graph here, we already found that we had 8 and 16 here, but now we want to look at 2/5 of these distances. And so if we use our formulas, we end up with 2.4. That's just what we do if we add -4 and 6.4. And for y, we get 8.2, which is what we get if we add 5 and 3.2. So our point will be 2.4, 8.2. Now, what if instead we were starting at point D and going 2/5 of the way along AB? Would that give us the same answer? Well, no, this point's going to be closer to D, and the other one's close to C. So now we're going to use the other form of the formula. We're going to start with the coordinates from point B and subtract. So for the x coordinate, we start with 12. We subtract 2/5 of 12 minus -4. And we end up with 5.6. And a similar idea for y. We start with 13, and we subtract 2/5 of 13 minus 5. Gives us 9.8. So that's the location of point D. And if you notice, that is not the same as point C. So even though we were talking about 2/5 in each problem, we're starting at a different endpoint. So it's going to affect what our answer is. Now, another way you could have solved this is if you wanted to instead look at starting at point A again. But if we're starting at point A, it's not going to be 2/5 of the way away from A. It's going to be 3/5 of the way of the distance away from A. So we could use the other formula, but instead of 2/5, we'd have 3/5, right? 1 minus 2/5 is 3/5. So here they tell us we want to put R on this segment so that the ratio of PR to RQ is 7 to 3. So how is this different from before? Well, this is a ratio of a part to a part. And so we have to be careful. So R is going to be somewhere closer to Q because RQ is 3 times some number, and PR is 7 times some number. So we could think of this 2 different ways. We could think of R as being 3/10 of the length of QP away from point Q. Or we could think of it as being 7/10 of this length away from point P. So if we use the first method, let's see, so we start with Q, which is the point 0.04. So 0 and 4, we add 3/10 of this difference, which is 10, and 3/10 of this difference, which is 6. Or we could go the other direction, start with P, and go 7/10 away. And so R has the coordinates of 3, 5.8, no matter which formula you use. In this lesson, we learned how to divide segments proportionately. Thank you for watching this video.